Get started with some practice. Our first question is to prove that lines A and B in this figure are parallel. Now, in geometry, when we hear the word prove, we should go through an actual geometric proof. I'm going to do a little bit more of that later. For right now, we're going to be pretty informal as long as we state clearly and completely what's happening. So how do I prove that? And I'm looking at this figure over here just to be clear. How do I prove that lines A and B are parallel? Well, I'm going to say angle 1 is congruent to angle 2, and they are, let's see, those are corresponding angles on the same side of the transversal and on the same side of their respective lines. They're both below their respective line. So, and they are corresponding angles. So, according to our first postulate, that means that the lines A and B are parallel because it said if there's a transversal that crosses two lines and the corresponding angles are congruent, then that means that the lines are parallel. So let's see, angle 1 is congruent to angle 2, and they are corresponding angles. So lines A and B are parallel. Okay, that is how we do that. Let's take a look at letter B. Prove that lines U and V in this figure are parallel. This is going to be according to theorem. Let's see. Oh, look at this. We don't have congruent angles, not right off the bat. So first of all, I need to prove that angle 2 is the same as angle 1. How am I going to do that? Well, if I go all the way back to theorem 6.3, states that a linear pair of angles is supplementary. So angle 2 plus 3 equals 180 degrees. And then I'm just going to state, since angle 3 is 111 degrees, that means that angle 2 has to be 69 degrees and is congruent to angle 1. All right, and then angles 1 and 2 are congruent and alternate interior angles. If you look, they're alternate interior angles. They're on opposite sides of the transversal, but between the two lines. So because angles 1 and 2 are congruent and alternate interior angles, according to theorem, let's see, that's theorem 12.1, A and, let's see, actually this is U and V are parallel. All right, let's take a look at letter C. Letter C is an easy one. Identify the alternate exterior angles. Well, if I look at this drawing, 1 and 7, 4 and 6 are my alternate exterior angles. Opposite sides of the transversal. This L is the transversal. And they're on the outside of the two lines. So 1 and 7, 1 and, let's get the word and there, 7. And then 4 and 6. Now, letter D. Given that 1 and 7 are congruent, prove that lines M and N are parallel. Well, that's theorem 6, let's say 6. Theorem 12.2 states that if alternate exterior angles are congruent, the lines that the transversal cuts, this is probably the best way to say it, are congruent. So what am I saying? Are parallel. Hope I didn't make that mistake anywhere else. The lines of the transversal cuts are parallel. Therefore, let's see, we have M and N are parallel. All right, letter E. Identify both pairs of same side interior angles. 3 and 8 are same side interior, 2 and 5. All right, now letter F is a hard one. Given that 2 is congruent to 6, use theorem 12.3 to prove that lines M and M are parallel. Now, 2 and 6 are corresponding angles. So it'd be really easy to use the postulate in this lesson to prove this. However, I can't say for sure, like I'm not supposed to use the postulate, I'm supposed to use theorem 12.3 about same side interior angles. How do I do that? Well, again, I'm going to go back and refer to theorem 6.3. Theorem 6.3 states that a linear pair of angles is supplementary. So in that case, let's see, 2 is congruent to 6. What I need to do is prove that 5 is a linear pair. I know that 5 is let's see, it's same side interior with 2. And I need to prove that 5 is supplementary to 2. All right, so let's see, theorem 6.3 states that a linear pair of angles is supplementary. So that means that angles 5 and 6 are supplementary. Okay, so if angles 5 and 6 are supplementary, that helps, but it doesn't prove that angles 5 and 2 are supplementary, does it? Except if 2 is congruent to 6, if 2 is congruent to 6, and 5 and 6 are supplementary, that means that 2 and 6, let's see, 2 and 5 also must be supplementary. And let's just reason that out for a second. So if angle 2 is congruent to angle 6, they have the same measure. If two angles are supplementary, let's see, if two angles are supplementary to the same angle, they're congruent. The converse of that would be if two angles are congruent, they're supplementary to the same angle. And that would be true. That's one of the theorems that we learned earlier as well. So in this case, I can state this. It makes logical sense that if 2 is congruent to 6 and 5 and 6 are supplementary, because they're congruent, 2 and 5 must also be supplementary. And that's what I need to prove my statement. So if 2 and 5 are supplementary, these two add up to 180 degrees, then according to theorem 12.3, since 2 and 5, angles 2 and 5 are supplementary, then M and N, let's see, and I should say, and 2 and 5 are same side interior angles, then M and N must be parallel. Okay, now that was a lot. There was a lot to write, but it's kind of important. When we have those proofs, you have to refer to earlier theorems. If I was being even more thorough, I would look up the theorem that relates to this statement here and state the theorem to prove my point even more clearly. Let's move on to letter G. Letter G, Spear Boulevard crosses Fox Street, Elati Street, and Delaware Street. Give the geometric term for Spear Boulevard. If it crosses Fox Street, let's see, where is Fox Street, Elati Street, and Delaware Street? Why, I would call Spear Boulevard a transversal because it crosses other lines. Now remember, even if those three lines aren't parallel, it doesn't really matter because a transversal just crosses two lines, not necessarily two parallel lines. Now, we can prove that the streets are parallel to one another, and the way that I'm going to do that is using corresponding angles. I'm going to say the angle between Fox Street and Elati Street, I should be writing these out correctly here. So Fox Street and Elati Street, I should say the angles are congruent, 33 degrees. And they are corresponding angles. So therefore, according to our postulate in the lesson that we just learned, Fox Street and Elati Street are parallel. And then the same applies for Delaware Street. Delaware Street is also a corresponding angle and congruent, 33 degrees. So it is also parallel. All right, so that's how you do it. You need to make sure that when it asks you to prove something, you're very deliberate in how you state your proofs. You probably want to refer back to previous theorems and postulates that we learned. It's a good idea to look those up. I wasn't looking up and stating the specific theorems and postulates, but it's a good idea to state the names of the theorems and postulates in your lesson. Make sure that you do that as we move on. It's going to become super important that you're able to do that moving forward when we get into like formal proofs. All right, and we are ready to move on to the practice problems 1 through 30.